Hi everyone, it's Math with AUB, day number 23 for the preparation of NET, ECAT, Federal Board and AgaKhanBoard. Today I have selected the topic for you, that is limit. That is limit. Some wonderful questions I have selected from limits, especially based on past papers and tests rather than from exercises. Let's see and find out our question number one. Our question number one reads as limit theta tends to 0. Limit theta tends to 0. Limit theta tends to 0. 1 minus cos p times theta over 1 minus cos q times theta. How to handle limit? It is like domain of the function, defined, continuity, check, put direct limit. We cannot divide with 0. We cannot divide with 0. We don't need negative sign in the real valued functions. We don't need negative sign in radical, and log is not defined for whether it is ln or lg or ln for negative numbers. We have to restrict ourselves from these three things. We cannot afford 0 in the denominator. There is no concept of radical and there is no concept of log. Check this one. Theta 0. Q times 0 is 0 and cos 0 is equal to 1. Cos 0 is equal to 1. Theta, limit theta tends to 0. Q times 0. Q times 0 means 0. Q 0, cos 0 is equal to 1. Cos 0 is equal to 1. So 1 minus 1 leads us to division with 0. That's absurd in mathematics. Then we have two possibilities, whether rationalize or apply identity or apply Hospital rule. Just apply a little tiny identity. 1 minus cos is equal to, in half angle, 2 sine square half of the angle. And similarly 1 minus cos, 2 sine square half of the angle. 2 cancelled out. 2 cancelled out. Taking the assistance of our famous identity from the limits, that is sine theta over theta is equal to 1, we are going to arrive at the result. 2 cancelled out, that square belongs to overall. We need p theta over 2 here, divide and multiply by p theta, and here q theta upon 2 square is there. So handle it very efficiently and carefully. Overall square sine p theta over 2, divide and multiply the angle, p theta over 2, divide as well as multiply. What about this? What about this? Handle this one as well. Handle this one as well. 1 over sine q theta over 2, divide and multiply by q theta over 2. It's divide, it's multiply. Overall square. Now according to limit theta tends to 0, sine theta over theta is equal to 1, where theta is measured in radian. It's equal to 1, it's also equal to 1. What remains? P theta over 2 over 1 over q theta over 2 whole square. Q theta, theta over 2 cancel. What remains? P over q whole square. So our result is p square over q square. So option number 1 results in p square over q square. There is another method, or Hospital rule, one can apply at to achieve some good score within no time in limits. Let me show you this one as well. Same limit theta tends to 0, 1 minus cos p theta over 1 minus cos q theta. Applying direct limit, q 0 to 0, cos 0 is equal to 1, denominator is 0, we cannot divide with 0. Apply Hospital rule. Derivative of 1 is 0. Cos means negative sine p theta. Then angle of the argument or inclination angle, it's p. Overall 0 minus sine q theta times q, minus plus. There is p sine p theta over q sine q theta. Apply limit, q times 0, 0, sine 0 is 0, sine 0 is 0. Still we are in upon 0 form. Again differentiate. P times derivative of sine is cos p theta times p over q, derivative of sine is cos q theta times q. Now it will become p square over q square. Our limit is 0, q times 0 0, cos 0 is equal to 1. So it is 1, it is also 1. So we arrive at the same result, that's our p square over q square, p square over q square. One can also utilize rationalization with numerator as well as denominator. It is going to be lengthy and cumbersome. I discard it. Moving to question number 2. Moving to question number 2. At our FSC level or SSC level, we are familiar how to handle a square minus b square or difference of 2 square. Just get along. X minus 6 over root x minus root 6. Put direct limit under root 6 minus 6. Division with 0 is not allowed. It's up to you whether to rationalize or factorize. Let's see the difference of 2 square in its real voyage. X can be written as root x square. 6 can be written as root 6 square over root x minus root 6. Factorize the difference of 2 square x minus 6. It will become one bracket positive, other negative, under root x plus root 6, root x minus root 6. Overall, root x minus root 6 cancelled out. Now there is no more denominator. Put limit, it will become 6 plus root 6 plus root 6. 2 times root 6, 2 times root 6, 2 times root 6. Or you can apply Hospital rule on that. Or you can rationalize even. Under root x plus 6 divide and multiply as well. You can. Like this, it is the same situation. So let me give you an idea of Hospital rule. Limit x tends to 6, x minus 6 over root x minus root 6. Denominator is 0. After putting direct limit, apply Hospital rule. Differentiation of numerator is 1, 6, 0. What is a differentiation of root x? 1 over 2 root x. 1 over 2 root x. 1 over 2 root x. It is in double upon, it will be turned into numerator. Apply limit 2 times root 6. 2 times root 6. 2 times root 6. You should be multi-dimensional to arrive at the result to hunt the questions of limit. Moving to question number next, that is limit x tends to 0, x tends to infinity, a raised x, sign argument is b divided by a raised x, A good question, What is this? Limit x tends to infinity, a raised x, sign limit x tends to infinity. Look, infinity is infinity, b over x. When x tends to infinity, it will result in 0. As the denominator increases. The quantity vanishes. It is going towards 0. Then we apply same formula, sin x over x, it's equal to 1. How? Let's see and find out. Sin b over a raised x. This one can be written as 1 over a raised x. Upon another upon, it will be in numerator. So from this, there is b, there is 1 over x. There is deficiency of b. Divide and multiply by b. Here. Multiply, divide as well as multiply. So it's 0, it's tantamount to limit x tends to 0, y tends to 0, sin y over y, that's equal to 1. So it is equal to 1 times b, it's RB. 1 times b, it's RB. So option number B, that's B also in that case. What is our next question? Limit n tends to infinity. Good one. For limit questions, either the possibility is limit is any real number, or infinite. Let's see in that case. Limit n tends to infinity, 5n plus 1 overall 5n raised n, 5 times n raised n. In case of infinity, overall power is variable, then there are two possibilities. Only there is infinity, its formula for E, which states that limit n tends to infinity, 1 plus 1 over n, there must be n over 1. There is 1 over n, there is n over 1. And another formula for same is limit n tends to 0. Then switch over these two quantities, 1 plus n raised over 1 over n. Then n over 1 will be there, 1 over n will be there in case of 0. That's for infinity. Here is infinity. You try to shape this one. Try to shape this question like this by separately dividing 5n divided by 5n. 1 over 5 times n raised n. Cancelled out. Now our question is taking shape. 1 plus 1 over 5n raised n. There is 1 over 5n, there must be 5n over 1. 5n over 1. So divide and multiply by 5 in the power to get this identity. Limit n tends to infinity. 1 plus 1 over 5n raised, it can be written as 5 times n, multiply 5 as well as divide. Now look at 1 over 5n, 5n over 1. Same situation here. It is tantamount to e overall power is 1 over 5. 1 over 5. E raised 1 over 5 is our answer in that case. E raised 1 over 5 in that case. Option number A. The final question that I have selected as it is from Sindh board. Sindh board. Very famous question from our limit section, especially this one and this one. These two questions are present in federal board as well as our Sindh board. I have selected these two questions, that's why. Now our question is limit. Final question of the limit for today. Limit x tends to a, x raised m minus a raised m divided by x raised n minus a raised n. Same strategy. It's not infinity. Put direct limit a raised n minus a raised n. So denominator is 0. We cannot divide with 0. Apply Hospital rule, or for subjective wise, either you can divide by x minus a because x minus a is a common factor into that, or you can switch over to suppose x is equal to a plus y such that y tends to 0 and it is going to be cumbersome. Apply Hospital rule. M times x m minus 1, that's our constant 0. Differentiation of constant is 0. N times x raised n minus 1 minus 0. Now there is put limit x is equal to a, so denominator doesn't vanish. It's our answer. M times a raised m minus 1 over n a raised n minus 1. It's our m over n. Here bases are same. Bases are same. They are in divide. Subtract lower power from upper power or upper power from lower power. We are subtracting lower from upper one. M minus 1. It will become negative n plus 1. Positive will become negative. Negative will become positive. Cancelled out. So we have m over n a times m a raised m minus 1, m minus 1, m minus 1. So our option in that case is A. Option in that case is A. That's my tiny effort to explain to you limits. Some 2 to 3 questions still are missing for the next frame. What I have selected for you, it is going to work for you. Let me share with you. These are the 2 books that mostly I have referred from for the selection of these questions that I have just solved. It's my tiny effort on day number 23 for you for limit wise. It's all by itself. Next.